Hello everyone, my name is Bhavana from SR University. As part of our capstone project, our team members developed a project called Phishing Website Detection under the guidance of Mr. P. Shravan. Let's get into presentation of our project. And these are our team members: Harshavardhan, myself, Soumya, Sanjana, Parvez. Abstract: due to increase of technology, cyber frauds are increasing, especially phishing attacks. Scammers send some fake website links through emails, messages, etc. If we log into that websites, they will took our user credentials related to banking. Uh, this leads to financial losses, breaches of personal data, and weakened securities. So to avoid this, we developed an application using deep learning techniques, especially ANN. Problem identification: phishing attacks are like online scams where scammers trick people into giving away their personal information. So we need a smart system that can spot these scams and protect people's information effectively. We aim to build such a system using advanced technology to keep people safe online. We researched some previous papers. We come across this fish array. It utilizes combination of CNN and LSTM to examine both the text content and URLs within the tweets for real-time phishing detection on Twitter. Phishing detection based on hierarchical attention network. It scrutinizes email text and headers effectively as either phishing or legitimate. Phishing detection using neural networks and feature selection. The system employs a multi-layer perceptron and decision tree to classify emails based on their phishing characteristics. Objective: our objective is to develop a deep learning model capable of accurate detecting phishing website by analyzing various features and patterns inherent in the website content and structure. Proposed solution: our aim is to develop an accurate and efficient deep learning model to detect phishing website and a user-friendly web application for analyzing and classifying both phishing and legitimate sites. Here we used six models in our project. They are decision tree, random forest, multi-layer perceptron, support vector machine, CNN, and ANN. Existing system: some researchers have used machine learning algorithms such as CNN and recurrent neural networks to analyze website features and identify potential phishing sites. In proposed method, we use artificial neural network ANN in detecting websites using deep learning. It has ability to learn, adapt up to complex patterns and features in data. It automatically extracts relevant features from the input data such as URL structures, content, visual elements without the need of for explicit feature engineering. We used tools like Google Colab for running machine learning and deep learning models. We used Python for specific libraries and frameworks. We used TensorFlow or Keras framework, Scikit-learn framework. We used libraries like Pandas, NumPy, Matplotlib. We collected URLs from PhishTank, an open source service. PhishTank provides phishing URLs in formats like CSV, JSON, updated hourly for legitimate URLs dataset from the University of New Brunswick. In pre-processing, we have data cleaning, means removing duplicate to prevent bias. Data standardization means standardized features to have mean of 0 or variance of 1. Feature extraction means to identify and select relevant attributes for the model. Data set splitting means divide the data set into training and testing sets. Ensure a representative distribution of data across splits. Feature extraction: features are extracted from URL datasets. These extracted features are categorized into address bar based features, domain based features, HTML and JavaScript based features. Address bar based features are domain of URL, IP address in URL, at the rate symbol in URL, length of URL, depth of URL, redirection, HTTP or HTTPS in domain name, using URL shortening services like tinyURL, prefix and suffix of hyphen in domain. Domain based features are DNS record, website traffic, age of domain, and period of domain. HTML and JavaScript based features are iframe redirection, status bar customization, disable right click, website forwarding. Here we have 17 data frames like having IP, have at URL length, URL depth, etc. All these together 17 data frames are extracted from the dataset. We trained our model through a mix of deep learning models, ML, multi-electron perceptron, and machine learning classifier like decision tree, random forest, SVM, etc. for phishing website detection. Here we used a dataset of phishing and legitimate URLs from Fish Tank and University of New Brunswick for model training and testing. Extracted features from URLs for model input. Highlighted the success of multi-electron perceptrons in accurately detecting phishing websites. Predictions. After model training, the focus shift to applying the model in real scenarios for phishing website detection. We have feature analysis for prediction. Analyzes URL features, domain information, and web page content. Classifies websites as phishing or legitimate. Provides a confidence score to indicate certainty of the prediction. We have training accuracy and testing accuracy. We used multi-electron perceptron, random forest decision ring. From all this, we get multi-layer perceptrons as the highest percentage in testing and training accuracy. Conclusion. Our deep learning model demonstrates strong performance in phishing website detection.
Hello everyone, my name is Tangilapalli Harshvardhan and I'm from Missar University. So as a part of our capstone project, we have worked on phishing website detection. So I'm going to explain the coding part of our project. Here, as you can see, this part of the code is about loading the data and visualizing the data. As you can see, this is the visualization of our data set. And the next step is dataset pre-processing. In this step, we will remove the data for null or missing values. As you can see, these are the values we attributes and which has null values. So we are going to delete these things and shuffling the rows in the dataset accordingly so that it will be easy while we'll split the data into train and testing. And here we are going to split the data into training dataset and testing data. So in our project, we are going to use machine learning models and training, and also we are going to use deep learning methodologies also. So initially, here we go with machine learning models. So we use decision tree, random forest, multi-layer perceptrons, or ANN. So we will take the best thing of these machine learning models, which has the best accuracy. So initially, we will go with the decision tree classifier. So here is the decision tree classifier coding part. Here we will test the data and we will train the data and we will check for the accuracy. Here you can see the performance evaluation of the decision tree. Here we got accuracy for training data is 80% approximately, and here we got 79% for testing and storing the results. So we can compare later and we will take the best one from these things. And next we go to random forest classifier, importing the model from libraries, and we are going to train and test the data. And we got an accuracy of 80% also for random forest on training data, and for testing the data we got 81%. And again we will show the result. And here we go with multi-layer perceptrons. So in this model we are importing the model from libraries. I mean multi-layer perceptron from libraries. Then next we are going to training and testing the data. Here we can see the accuracy for on training data is 85% and test data is also 85%. We will show these results. After that, we will go for ANN, importing the required libraries, and then next training the data, testing the data. After testing the data, here you can see the performance. We got very less accuracy of 62% and 60%. After that, store the data. And then next we go to deep learning methodologies. In deep learning methodologies, we are using here CNN, that is convolution neural network, and importing required libraries from the library, Python library. And then next training the model. And then next evaluating the model. And here we can see the accuracy for CNN we got is 83% on training data and 82% on testing the data. And we will store these accuracies to compare later and take the best one out. So, and then next while comparing here, we can see the random forest has these accuracies and we can see the best one out of these multi-layer perceptrons. So here we try to use convolution neural network, but multi-layer perceptrons has the more accuracy. So we are going to take multi-layer perceptrons as our main algorithm to predict the phishing websites. As you can see, the train accuracy comparison between these models, and then test accuracy comparison. And then we are going to create a pickle file for later for prediction also. So When we run this Flask application, we will be redirected to this link. And here we can see our phishing website detection. So this is a phishing URL, and we are going to check here. So here you can see the website is 100% unsafe to use. You can still want to continue. You can click this to redirect to the website page, and we will go to LinkedIn now. Here you can see the website is 100% safe to use. Then you can go continue to the website. Thank you.